Welcome to Hardware Development Series. In this series, we are going to walk through PCB designing, manufacturing and assembly process of this lithium-ion battery Rechargehub. We are going to design this PCB with Altium Designer 20 and then we will get this PCB manufactured by PCBWay.com. We all know that PCBWay.com is an online PCB ordering platform where we can get our PCBs delivered at our home with simple steps. Currently, PCBWay has started PCBWay Big Sale due to Christmas. There are so many exciting offers. Get your PCBs ready at PCBWay.com. The link is in the description below. Coming to the Altium, you may ask why only Altium? If you have the same doubt, then you should see this.
Altium does push and shove objects, length tune with a built-in electromagnetic field solver, and route at any angle. Schematic capture is agile and intuitive, enabling users to design flat and hierarchical projects with ease. And with the world's largest international community of electronics design professionals, you're never alone.
That's why I choose Altium. Not only me, Altium is widely used by all multinational companies in the field of electronics like Texas Instruments, STMicroelectronics, Siemens, Seagate, Philips, and Microsoft, HP, Lenovo, and some other companies like Audi, Boeing, Broadcom, and even NASA is also using Altium products for their design. So let's see how we can design our own PCB with Altium Designer 20. I assume you have already downloaded and installed Altium Designer and completed all necessary onboarding steps of Altium Designer software. If you didn't do that, I have given the Altium Designer download link in the description. You can download and follow the instructions to complete the setup. So let's dive into the episode. Launch the Altium software from the Windows menu. It will take less than 2 minutes to load the software based on your system performance. This is the Altium Designer homepage. Here we can get the latest articles and videos of the news and updates of Altium Designer. We also have a learning center, Altium community, support and documentation. This panel is a project panel. Altium uses panels to provide access to information and tools. To access the list of the possible panels in the Altium Designer, left click on the Panels button which is at the bottom right corner of the window. This opens up the menu with the various entries. The panel with these check marks are currently open and others are not open. Coming to the main menu, we have options like File, View, Project, Windows and Help. Let's start with a new project. To create a blank project, click the File, New and then Project. This enables a Create Project window to pop up. While there are many options, here we will start with the typical piece of project, the default PCB. Here we can name the project. We will call the project as Recharge_Hub and create it. This is the Altium project file. In this project, we can add schematic by right-clicking on the project file name and selecting Add New to Project, then select a schematic. This will add a new blank schematic to the project with a default name. At this point, you will notice there is an asterisk on the project file name. This indicates the project file needs to be updated due to the addition of the new schematic sheet. Right-click on the project file and select Save. Now we can save this schematic with the proper file name. Enter the schematic name and save it. Now the schematic has an entry in the project file and the asterisk gone. We can also add PCB file to the project in the same way. Then save it with the proper name as shown here. Here is the simple circuit to charge the lithium-ion batteries with TP4056 module. We have already covered this part in the previous episode. If you miss it by chance, you can follow the above link and complete watching it, and then come back to here. To place this lithium-ion battery on PCB, we need a battery holder. I found this SMD battery holder which is perfect for 18650 batteries. Let's try to add this component to the schematic. There are two ways to import component to the schematic. One is components. It has all default components. And the second one is manufacturer part search. This is an online searching tool. First search in components. The manufacturer number of battery holder is 1042P. In Altium component, the part 1042P is not available. So let's try in manufacturer part search. Here we can find this part, but we are not able to place it. Why? Because this part doesn't have any schematic symbol or PCB footprint. Thus, we cannot add this to the project. So the only way left is to install the Altium library loader. Visit the Altium library installation page, download the file, extract it, rename it as .exe and then install it. Please note that whenever you are installing this tool, the Altium should be closed. After installation of the tool, relaunch the Altium software. Now you can see Altium library loader present in the file menu and tools menu, as mentioned in the instruction guide. Now launch the tool and search for 1042P part. Verify the part and click on Add to Design. That's it. The battery loader added to the schematic, and that can be found on the bottom left corner of the schematic. Now the next task is to add TP4056 module to the schematic. In components and manufacturer part search, TP4056 is not available. It is also not available on the Altium library loader. Oh my god, what should we do now? How can we design a PCB without a component? Did we stuck here?
Definitely not. No, definitely not.
Definitely not. Altium can help us to solve it. That's why Altium is the standard PCB designer. In Altium, there is a feature to design our own schematic libraries and PCB libraries, which are not available anywhere. So let's design our libraries. To add PCB libraries to the project, go to the project and select Add New to Project and then select PCB Library. A blank PCB library file will be added to the project. Rename with a proper name and save it. To design a PCB library, we should have the measurements of the desired component. Here are the blueprints of TP4056, which has all required measurements. Let's come back to the PCB library file. Here you can see a mark on the screen, which is called as origin point of the PCB library. If you move the cursor around, you can see the values of X and Y coordinates are changing according to the cursor movement. The values in mils format. The 1000 part of inch is called as 1 mil. Let me first take a pad and place it at the origin point and name it as IN positive. The distance between IN positive and IN negative terminals are 14 millimeters. So 14 millimeters equals to 551.18 mils. So the X and Y coordinates of IN negative will be 0 and minus 550. The 551.18 rounded to the nearest multiple of 5, which is 550, and added minus to the 550 because it is in the minus Y axis. So let us place IN negative pad on the same coordinates and rename it. Coming to the next pads, out positive and out negative, the distance between IN positive and out positive or IN negative and out negative terminals is 23 millimeters. 23 millimeters is equals to 905.512 mils. So the x and y coordinates of out positive and out negative will be 905, 0 and 905, minus 550 respectively. So let's place them at the same location. Then the distance between out positive and B positive or out negative and B negative is 2.54 millimeters, which is 100 mils. Then the coordinates of B positive is 905, minus 100 and B negative is 905, minus 450. So let's place the pads at the same location. Total 6 pads are placed at their respective coordinates. Rename them with the proper names. Now let's draw a top silk layer with an outer boundary with 60 mils distance. Also annotate each and every pad on the top silk layer. After completing all these steps, save this file with proper name. I think we have managed to make this PCB library look similar to the blueprint. Hence, our mission accomplished. The next part is to create a schematic library for TP4056. Schematic library is just a representation of pins. To add a schematic libraries to the project, go to the project and select Add New to Project and then select Schematic Library. A blank schematic library file will be added to the project. Rename with a proper name and designator and save it. Let's place a rectangle to represent the TP4056 module. Then we can place pins to connect with external circuitry. Make sure the name of the pin should be inside the rectangle box. To avoid confusion, I am gonna place the pins similar to the actual TP4056 module. Yeah, placed all the pins in their respective places and renamed pins with actual pins. Now we need to attach the PCB library to the schematic library. For that, click on the Properties panel. You can find the Add option at the bottom. Select the Footprint option. This enables a PCB model selection window to pop up. Select the recently created PCB footprint model and click on OK. This will attach the PCB footprint model to the schematic. Then save this library with proper name. Come back to the project schematic page. Now we need to install this newly created library. For that, go to Components. Click on the hamburger menu and select the file-based library preferences. This enables the available file-based library selection window to pop up. Select the newly created libraries and click on the Add Library option. This will pop up a file manager window to select the real files. Select the both library files and click on Open. Then close the available file-based library selection window. Now the libraries are installed and you can find them in the Components drop-down menu. Now go to the Components drop-down menu. You can find the newly installed libraries here. Select the schematic library, right click on it and select Place option. The component will be attached to your cursor. You can rotate the component by pressing spacebar. You can take wherever you want on the screen and place it by clicking on the left click. Now the main components to charge a single 18650 battery are here. I wanted to add two more components to this circuit. The first one is 2-pin male header, which I wanted to use as a switch. The second one is a battery connector to provision another lithium-ion flat batteries. So let's add them to the circuit. Go to the components panel, select the miscellaneous connectors option and type header 2 and then place the component. I have selected this battery connector. So let's search the battery connector in the manufacturer search. Type manufacturer number here and the component is available. So place this too. All the required components are added to the sketch. Let's arrange and connect them. As I wanted to use this male header as a switch, I should connect it in a series. And the battery connector should be connected in parallel to the 18650 battery holder. Finally, the circuit is ready. This charges only one battery, but I need a charging hub that can charge up to 4 batteries. So let us replicate the same circuit for 4 batteries. Finally, we have a circuit to charge up to 4 batteries at a time. If you see here, these components have annotation with U question mark or IC question mark. If we give a serial number to each component, that will help us to eliminate confusion in the coming steps. So Altium can help us to get this task done with few mouse clicks. Altium has an automatic feature that will help us to annotate automatically. To do that, go to Tools, select Annotation, then select Annotate Schematic quietly, then allow it. That's it. It will automatically annotate all components without troubling us. I wanted to add few more components such as input status LED and male header for external input. So let's do that quickly. A male header from Altium components and red LED from manufacturer part set is added to the schematic. Let's short all inputs of the TP4056 module and connect with LED and input male header. Then add a nets 5 volts and ground to the respective nets. Also add a ground net to the battery negative terminals. So the final schematic will be something like this. Save all the files before jumping into the next step. The next step is to add all these components to the PCB file, arrange and connect them according to the schematic, and then generate the PCB fabrication files. We will cover that part in the next episode. So that's it for this tutorial. See you in the next episode. Bye bye.